Hello everybody and welcome to NASA Rockets to Racecars curriculum, a session on Drag Race to Mars Engineering Design Challenge. Now this challenge focuses on building a structure, and I have here the materials for the activity, that will use drag to slow down a capsule with a payload to land softly and gently on a surface, in this case Mars. The materials that you'll need for this activity are one styrofoam cup. We recommend the 8-ounce cup, the smallest of them. Bigger sizes don't work as well, so 8 ounces styrofoam cup, 2 to 3 coffee filters, and depending on the age level, you can give these types of coffee filters or the ones that are flat and open up for the older group, for high schoolers. We recommend 2 different sizes of index cards. Here I have about 5 index cards, 2 different sizes, just to give the students options on their building design. Very important, 3 flexi straws to help them with the design. We also give them about 10 rubber bands, masking tape. It is important to use masking tape, and other types of tape don't really work with styrofoam. And then the payload, which could be a marshmallow, it could be 2 pennies, or both, something that has weight. And then scissors for them to cut and do any designs. With the marshmallow as a payload, it's important that it's fresh but not too fresh. So we recommend that you open the package so they're not sticky, but if they're dry and old, they weigh less than when they're still fresh but not as sticky as when you just pop them out of the bag. Those are the materials for this activity. This activity also brings a data sheet, so you can collect data as well and do some math as you're doing the engineering design challenge. The way that we like to do this is talk to the students about their focus, and the focus is to imitate how engineers, NASA engineers, who use the atmosphere on Mars to use drag to slow down the capsule for the Curiosity rover. A good way to explain drag is, of course, with a hand. They understand the question when you bring up the question of what happens when you put your hand out the window in this way, opposite to this way. So what will happen to your hand? Doing that example will really have students understand what drag means. For little ones, it's good to then move the hand as if it were a parachute, and then kind of do this motion so they understand that with a parachute we're using the force of drag to slow you down. Because usually kids love to go fast. Okay, so the idea is that they build a structure using all these materials where we put the payload in the cup, inside the cup, and then when we throw it or we drop the design from a certain height, we see how it slows down versus a capsule with the payload inside and no design to use air to slow down. Some of the recommendations for dropping height is 2 meters high, 6 feet, about 6 feet. That way the design actually, you see the design in action. But as high as you can hold it and drop it, that's good enough as well. There's others, if you have the space allowed, you can drop it from even higher. There's different designs that have come up from this activity. This is why we love this activity so much, because there are many designs every time that we've done this activity with students. Let me share some pictures here with you guys. So here are just a few designs that have come out from this activity. Again, the idea is to use drag to slow down the capsule. And here's one of the winning designs from 2014 Career Days. And there is an action. If you notice, the tape on the back is about 2 meters high. So we use the tape for the students to measure the height, the bottom of the cup to the top of whatever height you want them to drop is a good measure, so that everybody is dropping from the same height. So the bottom of the cup to the top of whatever measurement of height you're going to drop from. So a few instructions that you need to give the students is that we want to make sure that the payload, the rover, the astronaut, is able to come out without any obstructions. Okay? So it's important that the inside of the cup is completely free of anything. So that means that if they want to put a straw, that it's best to put the straw on the outside and not in the inside, because that would be an obstruction. So anything building should be in the outside of the cup. Also, we want to make sure that the payload, the rover or astronaut, has enough space to come out from the top. So if they do build over the cup, allow about 5 inches of space as a good measure, so that in the scenario of something coming out, it has the space to come out and not blocking the exit for that rover or astronaut. Also, the cup needs to land in this direction. So this is the bottom of the cup. This would be the top, just like it's designed for drinking, the same way for the challenge. And we want to make sure to iterate that this is the heat shield. And the heat shield protects from the heat and the friction that happens when you come into the atmosphere. And a good example to bring that is to clap your hands and rub them together, and they'll feel the heat coming in because of all of molecules in the atmosphere. So if you perforate or make any holes in your heat shield, that heat is going to come in and destroy your capsule and injure your rover or your astronaut. So important, no obstructions in the inside of the cup or in the top, so about 5 inches. And then no poking or making holes on the heat shield itself. But you can cut or make holes on any of the materials. So on the flexi straws, on the coffee filters, or on the index cards, students are able to make holes, cut them up, use the tape or rubber bands. Now, once you have the distance and you have a method to take the time, now you can calculate the rate of descent or the speed. So it's important for, this brings an opportunity to assign roles to the students. And so when these tests happen, they occur very fast. So there needs to be a dropper, there needs to be a timekeeper, and there needs to be a spotter, and then somebody to write down all the data. So at least 4 per group. And you can have 2 timekeepers. It's always neat to see the differences in the chronometers. This is a good opportunity to bring your own device and use the device to either take pictures. You can also have a videographer and have the slow motion portion of any device that you have. If it has a slow motion, then the students can review the design and really see what parts of the design work best with drag, using drag to slow down. So the dropper will drop the design, again, the bottom of the cup to the top of whatever measurement you have. The timekeeper or timekeepers, you can have 2, will have some sort of device, either a phone or a chronometer to take time. And then the spotter will say start or stop. This is going to occur very fast, maybe a second's time. So the timekeeper, in order to be precise, cannot start and stop while looking at what happens to the design. So the spotter will stand next to the timekeeper and physically or audibly say start and stop. It's not necessarily when the design drops, it'll start the design. Sometimes, depending if it has big parachutes, it takes a while for the parachutes to fill up with air, if you will. And then once it stops, then the spotter will say stop, and then the timekeeper will stop the time. And then the recorder will record those notes in the sheet. So there's a data sheet available with this activity. And let me show you the data sheet. And the data sheet is designed to put the team's name in different trials. This is a great opportunity to bring in that just because it worked once doesn't mean that it'll work again. So different trials, and then there's space to add if it reached a target. So you can add a target on the floor that they have to meet and make sure that they reach their target, yes, no, and that the design landed upright. We want to make sure that the payload survives. So landing upright is another characteristic that you can ask your students to meet. In this data sheet as well, there's space to record the speed or rate of descent by putting the distance and then the time right here. There is another version that you can also use that has a script already with it. And it's right here, and the link will be available for you guys, made available. The script on the top just describes what needs to be done. So they envision themselves as NASA engineers landing Curiosity rover on Mars and using the atmosphere to create drag to land this payload softly and gently on the surface of Mars. There's a materials list here, and then a smaller version of that data trial sheet. This activity is really good for grades 4th through senior 12th grade. With smaller kids, it's important to bring in parachutes so that they have a visual of what they can design, what have they seen that uses drag. And then for the high school, middle school, and high schoolers, then entering the vocabulary and using drag and the forces is really important. It's a good opportunity to do that. Other teachers have designed their own data sheet. And you see here a teacher, a 4th grade teacher from Lynchburg City Schools, designed her own sheet where the students write what is the challenge in their own words, and then have some design time for discussion as a group before they start the building time. So this is a great activity to work in groups. Groups of 4 is the best number for older students. Groups of 3 might be best for the younger students. And making sure that they have the roles and understand the roles so that everybody participates in the group. This is part of the Rockets to Racecars program, where we compare the science of aerospace with racing. And there's a lot of NASA correlations tied that you observe in racing. And the reason why we teach them through racing, because racing is the most highly attended sport in the United States. If you think Super Bowl, the number of people that go to watch the Super Bowl, it's that amount of people every single weekend between February and November. Another advantage to it is that you see engineering in action. Not every sport that you observe, you saw the engineering, the technical and science portions as the event is going on. But with racing, you really see it at every pit stop. And of course, with Rockets to Racecars, we have a variety of teacher opportunities. So if you are interested in learning about these teacher opportunities, just let us know. And to learn more about the other sessions in the curriculum. So thank you so much, and we hope that you use this activity in your classroom. If you do so, let us know, and we'll be more than happy to answer any questions. Thank you so much.